I talked a little bit about this software-defined networking this morning, things being virtualized, networks becoming software, going into the cloud. That means that the access that customer has, may that be a consumer, small, medium, large business, or enterprise, becomes extremely important. Bigger pipes, reliable pipes, availability, all those things are important. So how do we get there? We have multiple ways to get there. For fiber-fed networks, we are building GPON. In GPON, both aerial GPON and buried plan. Initially, we are trying to cover as many homes and businesses as possible on aerial fiber. But we have some specific innovation going on with a couple of universities that allows us to cover a lot more ground in a very short period of time with our own technology, yes. So that's important. At the end of the day, it's all economics. You have to reduce your cost per homes passed as fast as possible, and you have to add a reliable service in an agile way. So that covers GPON. Second thing is GFast. We have tremendous amount of MDU opportunity within our footprint, multi-dwelling units. Multi-dwelling units, they have a need for 500 gig type services. We are deploying GFast proactively in those units. Third, we have a lot of copper in the ground. I have news for you. Copper is here to stay. It's not going to go away. And technologies on copper have also evolved. If I told you 10 years ago that we'll be offering a gig on copper, you'll laugh at my face. Now, that's exactly what GFast does. Okay? So we are using GFast, vectoring, bonding, and other technologies to get at least 100 to 200 meg to most of our customer base. At the same token, wireless is going through a massive evolution. 5G standards are out. As soon as we have more spectrum available, which will be in a short period of time, we'll be able to evaluate this technology and see where it's cost effective to use wireless versus wireline to provide fixed broadband to our customers. Customer expectation will continue to grow. They would want better service, faster service. They would want more reliable service because they will have a lot more options. So as we move from a central office type environment, which is full of bays, takes a lot of power, lots of human power to maintain the central office, to a edge compute platform that is fully redundant, that is running all kind of virtual functions, we have to maintain same or better service and reliability on that platform. So I completely envision a world where we have two small boxes sitting, replacing hundreds of thousands of square foot and supporting hundreds of thousands of customers in a platform which is much more reliable than what we see today. Remember, as you distribute your services, your reliability actually increases. As your footprint goes down, your reliability actually increases. Your chances of failure are 1. If the whole box goes down, then you take a lot more customers down. So the way to build it is to ensure that everything is fully redundant and backed up by another site. You can afford to actually do that because it's so small, and you can distribute computing and virtual services across multiple geographies to support the same customer. Today's world, it's not possible in our central office. Central offices support a specific geography, a specific amount of customers, and yes, they are highly reliable, but then when it goes down for a long period of time.
Right.
In the virtual world, that would not be the case. You can spin up VMs fast enough, you can have them running in a redundant environment, and you can transition customer service without having them experience downtime. Yes, failures will happen, but how redundant we'll build the network, how resilient this network will be, that's what will make it better. Today in our environment, we have lots of data, but traditionally companies like CenturyLink only use 5% of that data. 95% was thrown in the river. Data has been collected for years.
Right.
It sits in multiple databases in multiple locations, and when you need some data to make a decision, it takes an army of people and weeks to get that data. So we have implemented a strategy where last year we acquired an analytics-based company called Analytics in the Bay Area. They have a model controller, so you can now model data and you can predict, but you have to feed it with data. That means you have to have a big data platform. We have just announced our partnership with Cloudera, and we have built massive, huge Hadoop clusters, and we are adding analytics as a service and big data as a service for both internal and external consumption. And depending on the use case, whether it's for marketing, whether it's for sales, whether it's for operations, you have different use for that data. Analytics is and will play an important role for our customers. Give you one example. In security, we have to now predict a failure or an attack on our network. In operations, we can predict a failure of a card or failure of a software module. In sales, you can predict which customers are more susceptible to keep your service or susceptible to churn, and being proactive about managing their expectations. Analytics and big data enables us to do these type of things, and we are totally 100% behind it.